All right, so let's talk about this upper air highway model that we have for how air flows from aloft down to the surface and back and forth. So we have a ridge here and a trough here in our upper air. And recall we talked about how when air starts to go into a turn, like a trough, it begins to slow down significantly. So we get a lot of convergence aloft. As the air comes together, as it slows down. What happens when the air slows down and kind of starts to pile up here? It needs to escape from this highway. So what it does is it begins to sink and comes down to the surface. Being that so much air is coming down to the surface and packing down at the surface, we get high pressure down here. And we can start having some anticyclonic flow over here. On the other side of the trough, we start to get low pressure developing because the air is escaping this high and it's going towards this low here. This low here is supported aloft by an upper air divergence. As the air begins to spread out on the other side of this trough. So the air is coming together over here and piling up on itself, and then once it makes it through the turn, it can start to spread out again and move a little faster. So we've got slowing as we go into the trough and moving faster as we come out of the trough. So our low pressure system over here, recall we talked about how we have cyclonic flow. And we have anticyclonic flow over here. And this would just be where you would insert your force balance winds on a curved surface, as we talked about in a previous video. So this is our upper air highway. Sinking air here supports sunny weather. And the rising air over here is what creates clouds, and thus like rainy, kind of overcast weather on this side. Within this trough system itself, there's typically an upper air low, kind of creating this trough. But this is the upper air highway.